the next step we're going to do on the subdivision plat is start creating these center lines. So don't forget that you are going to take it in a particular order. You want to start with the subdivision boundary first. You want to make sure you draw the whole boundary all the way around. And once the boundary is correct, you need to make sure that you go and check, like we said in the previous video, check any errors, make sure that it's less than 0.03 and extend and trim lines and so on and so forth. At that point, we then now continue drawing the next set of lines. So the next set of lines that you want to do would be the center lines. So we're going to draw the center line here to here. In this case, for Lanka Heights, is going to be these center lines, okay? Now, as far as the center lines, we need to know what point are we going to start with. In this case, I'm going to start from this point. So then the question is, how do I find that point? How do I identify that point? What's going to happen is you're going to go in here and you're going to use, along this line, we need to somehow, like I said in the AutoCAD file, we need to find that point somewhere on that center line. So once we find that point on the AutoCAD file, at that point is where we're going to start drawing the first center line this way. And then we'll continue with the rest of them. But the question is, how do I find that point? How do I find that point? Okay. So then what we're going to do is we need to identify that point on the plat. We need to look at this document and analyze the information to figure out how do I get to this point from this. And I'm going to go from this corner. It doesn't have to be this corner. It could be the other corner. How do I get this? How do I find this point on my AutoCAD file? What's going to happen is we already know, and please keep in mind, every single line within a lot has to have a bearing and a distance, okay? So we already know the overall bearing and distance of this entire line. It's northwest 0 degrees 33 minutes 12 seconds, a distance of 626.66, but that's the entire boundary line, okay? Well, that's really the bearing of this line. So we already know it's bearing northwest 03312. But what would be the distance from here to here? If you notice these small numbers, this small number, for example, the 124.71, is the distance bearing northwest 03312 from here to here. So that's this distance here, the 124.71. The distance from here to here is 96.67. This same thing here. So that same concept exists all over the place. So the distance from here to here is bearing 90 degrees southwest, but the distance, the overall distance is a 626.66, but the distance from here to here is 112.51. You need to know that because in some cases, if you're going to develop a site plan, for example, if you're going to develop a site plan, then on that site plan is where you would need to know the bearings and distances of each individual line on that lot. So that does happen. If you ever had to do a site plan for yourself or a friend of yours or something, you would need to know bearings and distances of the lot individually. So like this one that I did for a friend of mine, I needed to know the bearing and distance of each line individually for that one lot. So that one lot has bearings and distances. So in some cases, you'll get the overall of the subdivision boundary or whatever information you have, but then you need to know that information just for that one lot. So that's what the information that we're looking at, and that's what we're going to be using in this case to get the distance from here to here by simply going to the plat. And because with the fact that we already know that the 124.71 is the distance from here to here, the distance from here to here along the northwest 03312 is 80. The distance from here to this point is 59. The 59, I think it's 59.81. And then from here to here. Okay. So what we're going to do is we're going to simply add these numbers. We're going to take these four numbers and add them up. And I kind of nice in that I kind of wrote that for you, but I'll tell you right now, adding these four, you should do the math on your own just to make sure you're doing it correctly. But I'll tell you right now, it's going to be 310.71. 310.71 is going to be the distance from here to that point of the center line, considering these four distances. Then at that point, we're going to start drawing our line of 145.94, bearing northeast 90 degrees. First things first, 310.71 is our magic number that we need to consider. So how do I get that? Can I offset this property line here, 310.74? Unfortunately, not. You can't do that because this is happening, okay? You might think about the whole 0.03 issue and everything. Yeah, that could be the case, but the thing is, That's more complicated. Right now, we just basically I'll tell you, for the most part, offsets will not work. Why? Because I can tell you these two lines are not perfectly perpendicular. They are not at a 90-degree angle. So we can't necessarily use offsets. So how else can I do it? Can I go in here and draw myself a create line by bearing, northwest, 0 degrees, 33 minutes and 12 seconds, a distance of 310.71 to a point, and then go this way? I could. Or another thing I can do is I can simply draw myself a circle. Circles, as long as they're used correctly from this endpoint, I'm going to draw a temporary circle with a radius of 310.71. I'm using the circle simply to find that intersection. At that intersection is where then I'm going to draw my line by bearing from this intersection, and I'm going to draw that line with the bearing according to my plat of 145.94. 145.94 is going to be the bearing, the distance from here to here, bearing northeast 90 degrees. So I'm just going to go northeast 90 degrees, a distance of 145.94 from that intersection. So literally the circle was drawn just to simply identify the intersection and draw my center line. And then at that point, I'm going to go ahead and keep drawing my center lines. Now, as far as this center line, we have a bearing and a distance. So we have a bearing and distance. The distance is 170.29 from here to here. And then what about this one up here? If I look at this one up here, I look at the center line, I can see that I do not have a bearing. It's incorrect for me to say there is no bearing for that line. That is an incorrect statement. Okay. So what is the bearing of this line? Every line has to have a bearing. So what is the bearing of this line? Could I say, oh, it's the same as the boundary? That's the same bearing of this line. No, that is not a correct statement. You can't assume that. So you just need to kind of investigate the line, kind of look at it a little bit and just kind of follow it along. And then you'll see, oh, there's a bearing right here. And it says northwest 0 degrees. Is that the bearing of this center line up in here? It sure is. So now I know it's 0 degrees northwest. I also have several distances. I have a distance of 170.29, which is from here to here. I have the 220.30 from here to here. So where is this 390.59? The 390.59, this engineer just wanted to give you some additional information and tell you that 390.59 is from here all the way to here. It's just a combined distance. Okay, so you don't need all of that. It depends on what information you're needing. But at this point, I just need to go from this point to here, a distance of 220.30 bearing northwest 0 degrees. So I'm going to start with that one first. And then I'm going to talk about this one on the next step. Okay, so I'm going to go this way, 220.30 northwest 0 degrees. So I'm going to go back to Civil 3D, create my line by bearing. From this point here, northwest 0 degrees, 220.30 is this center line. Now to draw this one. Now to draw that one. So that one has a bearing that I just used right now, northwest 0 degrees, but it says northwest. The distance is 170.29 from here to here. That's pretty easy. But this one says northwest. If I were to go northwest from here, it's going to go this way. So for me to travel in this direction, I need to go the opposite of northwest. What is the opposite of northwest? North becomes south, west becomes east. So I need to consider that I'm going to draw this line into the southeast quadrant, a distance of 170.29. 170.29 is what I need to do. So I'm going to go over here and create line by bearing. The plat says northwest, but I need to go the opposite of northwest, which is southeast, bearing 0 degrees, a distance of 170.29. 170.29. Okay. And that's going to happen in several instances where we've talked about this. You need to flip the direction. This line right in here has a distance of 145.94. I'm sorry, 145.94 from here to here. From this point to this point is 324.65. The 470.59 is from here all the way to here. Okay. And same thing over here. We have a line here. 170.29 is the distance. Southeast is the bearing of this entire center line. So going this way, I will go south. Going this way, I'm sorry, I will go southeast 03312. This way, it's the same bearing, but I need to change the direction. So instead of going southeast, I need to go northwest 03312, a distance of 220.30. Okay. I'm going to stop this video at this point because I expect you to do that. On the next video, I'll show you how to create the right-of-way lines.